All right, welcome to Pre-Cal Lecture 5.2. What you're going to need for this lecture is your 5.2 note sheet and have your unit circle handy. All right, on your notes, you already have typed out the definitions of sine, cosine, tangent, cosecant, secant, and cotangent. So these are the basic trigonometric functions: sine, cosine, and tangent. And sine's reciprocal, so it's just the same as 1 over sine, is called cosecant. Cosine's reciprocal is called secant. And then tangent's reciprocal is called cotangent. Now we can relate all these, what I mean by op over hype and adj over hype. Okay, so that has to do with the sides of a right triangle. So just go ahead and draw this in that space in your notes. So this is angle theta. This is 90 degrees. This side across from angle theta we call the opposite. Okay, and I'm going to abbreviate it as OPP. This side right here we call the adjacent side. And I'll abbreviate it as ADJ, and this is the hypotenuse. Which we'll abbreviate as HYP. So sine is just defined. The sine of angle theta is the opposite over the hypotenuse. The cosine is the adjacent over the hypotenuse. Tangent is opposite over adjacent. And then you flip those. Cosecant, you flip sine. Hypotenuse over opposite. Secant is hypotenuse over adjacent. Okay, and cotangent, adjacent over opposite. Okay, so just the reciprocal. You just take whatever that fraction is for sine and you would flip it. Okay, so our first example is compute the functions for theta in the following triangles. So we have, and draw this triangle out. Angle theta, this is a right angle. And this is a famous triangle, the 3, 4, 5 right triangle. All right, so sine theta is opposite 3 over hypotenuse, 3/5. Cosine theta, adjacent 4 over hypotenuse, 4/5. Tangent theta, 3 opposite over 4 adjacent. And then the reciprocal functions, cosecant, which goes with sine, is 5/3. Just flip the fraction. Secant is 5 over 4. And cotangent is 4 over 3. All right, so that's all there is to it. Now there's an acronym that you can memorize. A lot of teachers do this. I really don't. I never really learned it this way, but it's SOHCAHTOA, pronounced SOHCAHTOA. Sine opposite over hypotenuse. Cosine adjacent over hypotenuse. Tangent opposite over adjacent. You can memorize that if you want. I kind of have just learned it from the pattern. I look at the triangle and I know the patterns. Okay, let's do the next example, and this one you'll want to have your unit circle handy. We're going to see where some of the famous angles on the unit circle come from. So it says find the trig function values for pi over, so here we are on your notes, we're right here in this middle second example, for the pi over 4 radian acute angle. Okay, so let's draw a right triangle here. angle is pi over 4. Okay, and so what we're going to do, pi over 4 is a 45-degree angle, okay? And so what that means is that if this is 90 degrees right here, then this would also be pi over 4, or 45 degrees. Both of them would be that. So that means these sides, this adjacent side and this opposite side, must be the same. So we're going to go ahead and give them a length, and it's a length of 1. That's how we come up with the unit circle. If this is the center of the circle, this point right here, okay, so what we're talking about on the unit circle is we're making a triangle from the center of the circle right here, okay, 45 degrees, or pi over 4 radians. So we can get the hypotenuse because we know that the hypotenuse squared is going to be the two sides squared. Add the two sides squared. So that's hypotenuse squared is equal to 2. So the hypotenuse would be the square root of 2. Alright, so the sine of theta is equal to opposite 1 over hypotenuse. So 1, or that, let's go ahead, since we know the angle, we'll put sine of pi over 4. So it's equal to the opposite 1 over the hypotenuse, the square root of 2. Now I'm going to go ahead and rationalize that. Square root of 2, square root of 2. Right? And so that would be the square root of 2 over 2. So let's see. You can see if you look at the unit circle, the way that you read it is, here's our angle pi over 4. Cosine, then sine. All right, first is cosine, then sine. So you can see that the sine of pi over 4 is the square root of 2 over 2. So that's where it comes from. The cosine of pi over 4 is going to be adjacent over hypotenuse, also 1 over the square root of 2. So when you rationalize that, just like we did above, root 2 over 2. So you can see the cosine of pi over 4, cosine is the first number in the parentheses. The way I remember it's the alphabetical. Cosine, C comes before S, so cosine and sine. So that's also the square root of 2 over 2. The tangent of pi over 4 is going to be opposite over adjacent, so 1 over 1, and that is 1. So you can get the reciprocal functions by flipping. Cosecant is going to be 2 over the square root of 2. If we rationalize that, which you don't always have to do, that's going to be 2 root 2 over 2, and the 2 over 2 cancels, so that's just root 2. All right, the secant of pi over 4, that's going to be 2 over the square root of 2, because I'm flipping the cosine. I flip the sine for cosecant, flipping the cosine. If we rationalize that, just like on the last one, it's going to, you're going to get 2 root 2 over 2, and so it's also going to be the square root of 2. And then the cotangent of pi over 4, we would just flip 1, and if you flip 1, you get 1. Okay, so that tells you how all these numbers at pi over 4 came about. Square root of 2 over 2, square root of 2 over 2. And I'll tell you another way to get tangent in just a little while. All right, let's do the next example. All right, so on this one I'm going to draw, we're at the example on the bottom of page 1 of your notes. So on this one we're going to draw an equilateral triangle. I'm going to draw it kind of big here. Okay, so if this is the center of our unit circle, let's say right there, then I'm going to give the length on each side a 1. Okay, so that would make the total length of each side 2. So again, this is an equilateral triangle. So that side is 2, that side is 2. And I'm going to split this down the middle with a height. Okay, let's move that little dot. All right, and I'll end up making two right triangles. So this is an equilateral triangle. That just means all the sides are the same. Okay, so we know this is 1, the hypotenuse is 2. We need to get the height. Okay, so with the Pythagorean theorem, we know that hypotenuse squared, 2 squared, is equal to the height squared. I'll say that's HT. Height squared plus 1 squared. Again, this is our triangle. Height squared plus 1 squared. So that means 4 is equal to, let's call that height y. So y squared plus 1. All right. So if you subtract 1 from both sides, you'll get 3 is equal to y squared. So y is equal to the square root of 3. So our height is the square root of 3. So now I've got a right triangle that's got all the sides. So let's get the trig functions for that. All right, so first, all right, so we need to get the angles. We know that's 90 degrees right there. Okay, and so what that means is for this equilateral triangle, all the angles are the same. Okay, if we got rid of that dashed line, I'm talking about the big triangle. They're all 60 degrees, right? A triangle has to add up to 180 degrees for the sum of all the angles. Well, in radians, 60 degrees is pi over 3. So I've got pi over 3, pi over 3 here. This whole thing is pi over 3. If we split that in half, I've got pi over 6. Okay, so what I did is I took the whole, this whole thing right here, pi over 3, split it in half, you'll get pi over 6. So now suddenly we've got all the famous angles on the unit circle in this triangle and in the one in the last example. All right, so we can get the sine of pi over 3. The sine of pi over 3 is going to be opposite over hypotenuse, square root of 3 over 2. The cosine of pi over 3 is adjacent over the hypotenuse, so 1/2. Adjacent side 1 over 2. Cosine adjacent over hypotenuse. The tangent of pi over 3 is going to be opposite root 3 over adjacent, 1. So just the square root of 3. All right, and you can flip those numbers to get the reciprocals. Now let's do pi over 6. So the sine of pi over 6 all right, sine of pi over 6, so we're going up here, is opposite 1 over hypotenuse, 2, 1/2. Cosine of pi over 6 is the adjacent side, that's the dashed line, the height of the triangle, root 3 over 2. The tangent of pi over 6, okay, here's pi over 6, opposite 1 over adjacent, root 3. If we rationalize that, I'll go ahead and do that, that's going to be root 3 over 3. You may want to memorize that tangent pi over 3 is root 3 and tangent pi over 6 is root 3 over 3, or it'll cause you more work. So let's take a look at the unit circle, all right, and see if we match. So pi over 3, sine is square root of 3 over 2, cosine is 1/2, right? That's where they come from. For pi over 6, that's this 30-degree angle. Cosine is root 3 over 2. That's what we said it was. Sine is 1/2. All right, so you can see that's where all of those numbers come from. All right, the examples will go quicker from here on out. So this is the summary of common trig angles. Now that you have your unit circle, this is just quadrant 1 of the unit circle in tabular form. So you don't really need to memorize this for now. You will eventually have to memorize the unit circle, but you don't have to do it for now. You just have to know how to read it. Cosine, then sine. Okay, here are the degrees, here are the radians. Okay, but that is just a summary of quadrant 1 in the unit circle. All right, let's go down to evaluating trig functions for an angle. All right, so we're going to use the Pythagorean theorem here. And I can go ahead, I'll go ahead and leave these up here. So our example says theta is an acute angle, and we have cosine theta is equal to 12 over 13. Now, 12 over 13 is not on the unit circle. It's not 1/2, 1, 0, root 2 over 2. It's not one of those famous, so this is if it's not on the unit circle, you can't just read it directly from the unit circle. What you have to do is draw a triangle. Okay, so we'll call theta here. Cosine is adjacent over hypotenuse, so the adjacent side is 12, hypotenuse is 13. We're going to use the Pythagorean theorem. Let's call this y. So I'd have 13 squared is equal to y squared plus 12 squared. If you do the math there, you're going to find that y is equal to 5. Okay, so we want to find the other trig functions. All right, sine is opposite over hypotenuse, so 5 over 13. Tangent, opposite over adjacent, 5 over 12. Okay, and then we can just flip. We would know the cosecant, 13 over 5. Cotangent, 12 over 5. And then the reciprocal of cosine, we've already been given that cosine is 12 over 13, so that's going to be 13 over 12. All right, not bad at all. Let's move on to the next example. All right, so the next one, finding the angle given the value of a trig function. If theta is an acute angle, sine theta is root 12 over 4. Use the table of common trig values. We're going to use the unit circle instead of this table. Okay, so we know that sine theta is the square root of 12 over 4. All right, well, square root of 12 over 4 isn't on the unit circle. So let's see if we can manipulate that. Square root of 12 is the same as square root of 4 times 3. We can bring that square root of 4 outside. The square root of 4 is 2. And 2 over 4 reduces down to 1 over 2. So square root of 3 over 2. All right. So we know that sine theta, we've manipulated root 12 over 4 and found out, hey, that's just the square root of 3 over 2. All right, well, where is the sine theta, the square root of 3 over 2? Remember, sine is the second one. Well, that's at 60 degrees, or pi over 3 radians. Now, it happens again in quadrant 2, but we'll move on to that in a future lecture, okay? But for quadrant 1, we're looking at 60 degrees, or pi over 3 radians. All right, so the purpose of that was just to show you, hey, you can manipulate these radicals and get it to match something on the unit circle, potentially. Okay, so let's go on to page 3, which is the last page. And this one says using trig functions to find the unknown sides of right triangles. So solve for x. In this one, you need to draw out this triangle. The angle is 32 degrees. The opposite side is 20, and we want to solve for the hypotenuse. So which trig function uses opposite and hypotenuse? Well, it's sine. Okay, so we would know that sine of 32 degrees is equal to 20 over x. So solving for x, we bring x out front. That's going to be 20 over sine 32. You need to put that into your calculator. Make sure your calculator is in degrees. All right, and you should get 37.74. If you don't get that, then maybe your calculator's in radians. If you have a TI, you would just go to mode and change it. You'll have to, on the test for this section, you'll have to be able to go back and forth between degrees and radians. All right, and then one more, and that'll finish up this lecture. So we want to solve for x. And this is the triangle of interest. All right. Solving this time for the adjacent side. 42 degrees. The hypotenuse is 8. So which trig function uses adjacent and hypotenuse? It is cosine. So we can rewrite this as the cosine of 42 degrees is equal to x over 8, adjacent over hypotenuse. Multiply both sides by 8, and x is going to be 8 times the cosine of 42 degrees. Put that in your calculator, and you will get 5.95. Again, make sure your calculator's in degrees. If I had given you this in radians, let's say I'd given you pi over 5 radians, then you would change your calculator to radians and do the same thing. All right, so give that a try in your calculator. Make sure if you're not getting that, you ask questions. And that does it for lecture 5.2. And I will talk to you next video.